Hey everybody, this is 3-1 patterns, and I thought I'd take some time to go over this to you guys. We did this in class, but I thought for people that weren't there, this would be helpful. Some definitions here: pattern, sequence, and term. Patterns are a set of items, shapes, numbers, etc. arranged in following a specific rule. A sequence is a string of numbers that follow a pattern, and an individual element in a sequence is called a term. All right, so here's an example of a pattern. The numbers are increasing and they're going up by 3. Okay, this would be an example of an arithmetic sequence, and the common difference is 3. The common difference being the amount it's changing by. Okay, so here we go. Arithmetic sequences. There's basically two types of sequences we're going to worry about. One's arithmetic and another is geometric. Arithmetic, you're going to be dealing with a constant value they're changing by, whereas a geometric sequence is going to be a ratio that's being applied. Okay, so here's a definition we're going to use. We're going to say a numerical pattern that increases, or decreases at a constant rate or value. Okay, and that's called the common difference. Okay, it's a common difference. The difference between the terms in an arithmetic sequence. Okay, so let's do an example. Let's start with -5, and it goes to -1, and then 3, and then 7, and 11, and it keeps going. So this pattern is increasing by 4 each time, right? So if I look at this, I say to myself, all right, well, it went up by 4, up by 4, up by 4. Each time it's going up by 4, right? 4 would be the common difference. So D equals 4 in that case, all right? All right, geometric. So a sequence in which each term after the first is found by multiplying the previous term by a constant, call it R in this case, called the constant ratio. So essentially, when you're working with an arithmetic sequence, you're going to be adding. Now you could be adding a negative, so it looks like you're subtracting, but you're adding something, you're combining something. Whereas geometric, you're going to be multiplying. You're going to be multiplying by a ratio. Okay, the ratio there is called the common ratio. So the ratio of successive terms in a geometric sequence. So it's pretty easy to figure these out, right? So here you could always just subtract one term by the previous term, right? So 7 take away 3 would be 4. That'd give you the common difference. Or 11 take away 7 is 4. That's how you find the common difference. Here you're just going to divide. So I'll show you here. Let's go with, let's go 3, 6, 12, 24, 48, etc. Okay, so we're multiplying by 2 each time. Right, times 2, times 2, times 2, times 2, right? So the common ratio, if we did 48 divided by 24, we get 2, right? If we get, let's say, 24 divided by 12, 2, 12 divided by 6, 2. So that's how you can figure it out. Just take one term and divide it by the previous. All right, so now let's look at some of these examples. So the first thing it's going to do is going to give us a series of values. Let's zoom in a little more here. And it's going to ask us, one, to identify it as either arithmetic or geometric, and then figure out the common ratio or difference, and then identify the next two terms. So what we're going to do is, first of all, look what's happening here. So here it goes up by 12, right? Then it goes down by 24, then it goes up by 48. So this is not a constant a common difference. This is going to be a common ratio, okay? Because the multiplication is taking place here, okay? So that's going to be geometric. And we can tell pretty quickly by saying, all right, this is not a constant amount. The amount of change by here is not the same as this, therefore it's geometric. So we know it's geometric, so now we just have to take one term and divide it by the previous. So we'll do 8 divided by -4. And 8 divided by -4 is -2. And now you can see it. So -2 times this is 8, -2 times this is -16, so forth and so on. The next two terms, we'll multiply this. So this will be -64, and then positive 128. And that we found that just by simply multiplying this by 32 and then by -64. Okay, over here, it's going up by 4, up by 4, by 4. So this is arithmetic. We can tell because the amount is constant. So arithmetic. Common difference is 4. And again, you can figure this up by just subtracting. 7 take away 3 is 4, 11 take away 7 is 4. Next two terms are going to be 15 and 19. Okay. So here we got 1/3, 139. So the amount it's changing by is not the same. So we already can tell it's geometric. And we can take one term and divide it by the previous. So 3 divided by 1 is 3, 9 divided by 3 is 3. 1 divided by 1/3 is 3. So common ratio is 3. Next two terms, we're going to multiply by 3, so 27. And what's 3 times 27? Let's see, 1, carry the 2. So 81? I think it's 81. Yeah, it's 81. So type of sequence here, so it went down 3, down 3, down 3. So we're going down 3 each time, so this is arithmetic. Common difference is -3. Next two terms are going to be -8 and -11. Here we go up 6, up 3. Yeah, so we changed the amount. Now they only give us 3 terms, but you can tell that the amount we changed by was different. This one, we added 6, we added 3, so it's not going to be arithmetic, it's going to be geometric. Now if you're having a hard time by doing it by looking at the values, you could actually just try subtracting, like -6 minus 12 and -3 minus -6, and you'll find that the amount is different. You could do it that way as well if you want to. It just takes more time. Common ratio, I don't know, let's figure this out. So -6 divided by -12 is going to be positive 1/2. So yep, we're just multiplying it by half. So this would be -3 over 2. And this would be -3/4. Yep, multiplied by half. All right, here we have up by 2, up by 3. So the amount changed, so it's geometric. Okay. The common ratio, let's see, so 6 divided by 4 is, let's simplify that, it's 3 over 2, or 1/2. So 3 over 2 times 9 is going to be 27 over 2. And multiply that by 3 over 2. So 3 times 27 is 81 over 4. And we can't simplify that, okay? It's a weird one. Let's see. Yeah, did that right? Yeah, I did that right, okay. All right, sorry about that. All right, the last part here. It's asking us to draw the next two terms in sequence. This looks like a series of hexagons. I'm going to try my best here. Let's see what I can do. I'm admittedly not that great at drawing. There's 1, 2, no, oh shoot, I already messed it up. Look at that. No, I didn't. Okay. 3. Let's change a 4th one. And then the next sequence would be, well, I guess I'll draw it here. Now there should be 5 of them, right? So here's 2. Oops. 3. 4, and then 1 more. 5. Okay, here, oops, 0 square is 1 square, 2 square, so this is 1, 2, that's terrible, sorry. There you go. Not the best. You get the idea. I'll zoom out so you can see this. And then last one, yeah, sorry, you guys get to see my horrendous drawing skills or lack thereof. Okay, it's triangles. This should be now, there should be 4 squares. So 1, 2, 3, 4, and triangle. Okay. You can let the jokes commence by drawing. All right, so that is a little bit on arithmetic and geometric patterns. Hopefully that helps, guys. Let me know if you have any questions.